Hi, we have the AP Physics 1 past paper 2022. We are discussing free response question section. In this section, question 2 carry the 12 point, which in this question, two identical moons, moon A and moon B, orbit a planet. The mass m0 of each moon is significant but less than the mass mp of the planet. Okay, both moons have the same mass m0. At some point in their orbits, the planet and the two moons are aligned as shown in a figure. As you can see, moon A, moon B, and the planet. There is a distance between from the planet to moon B, RB, from the planet to moon A is RA. Now, the following dot represent two moons when they are at the location shown in a previous fig. On each dot, draw and label the forces, not components, exerted on moon A and moon B. Each force must be represented by the distinct arrow and directed pointing away from the appropriate dot. Okay. Now we have to discuss step by step what is happening. So the each moon feel the force of gravity from the planet and the other moon. So there are two objects around. So they both are exerting the force of gravity on each moon. From if we see moon A, so moon B is also exerting the force on moon A and planet is also exerting a force on moon A. So I have marked the arrowheads. Both are from planet A, planet to moon A, planet B, moon B to moon A. But in the case of moon B, now the moon B has the different scenario. If you can see that, if let's say what happened to the moon B is the planet is also exerting a force of gravity and moon A is also exerting a force of gravity on the moon B. So I have planned the B, there is the two forces A from moon A to B, from planet to the B. So that's the two forces acting in opposite direction. Now, next question. Consider the net gravitational force exerted on each moon due to the planet and the other moon. Justify why the magnitude of net force exerted on moon A could be larger than the magnitude of net force exerting on moon B. So, on moon A, the force from the planet and the force from the moon B act in the same direction. They added together, making the net force larger. That's the simple. From the you can see both forces are in same direction. The forces from the planet and the moon act in opposite direction. They partially cancel, making the net force smaller. So that's why the as comparison, moon A has a larger force as compared to the moon B. Okay. Now, the next part of the question, justify the magnitude of net force exerted on moon B could be larger than the magnitude net force exerted on moon A. We have to find out the reason. How is it possible that the net force on moon B can be greater than the from moon A? Now, moon B is much closer to the planet. Distance from the planet of RB is very less than RA. Gravitational force increases when distance decreases. So that's mean if R is less, then force of attraction is gravitational force is much larger. Now the planet of pull on a moon B is much stronger compared to everything else. This stronger pull might be larger than the total force acting on a moon A. So moon B could have the larger net force in that scenario if the distance is much less as compared to the A. If the distance is decreases, the force should be increases. If so, in that case, force much can be greater than from moon A. Now, derive the expression for both following quantities. Express your answer in term of m naught, mp, ra, rb, and the physical constant. Net force Fa exerted on moon A, net force exerted Fb exerted on moon B. We have to calculate the mathematical tool. Now, We have for the moon A, there is a net force summation FA. There are the two forces I have in previous fig we have indicated FAB, FA planet, both are in same direction. So simple algebraic sum is there. Gravitational force has the formula F is equal to G m1 m2 over r square. In that case, from A is the moon and the P is the planet. Planet mass has m naught, moon has mp. So our RA square distance between the planet and moon is RA. And the next force is the between the two moons. So both have the same masses. So m naught square RA minus RB is the distance between the two moons. So you can common gm naught, and this is the net force acting on a moon, a mathematical expression. Now for the moon B, both forces are in opposite direction, so there is a minus sign. So net force is equal to FB planet minus FBA. So from the first planet and the moon, G m naught mp over RB square. RB is the distance between the planet and the moon B, and the both distance RA minus RB is the distance between the two moons. So GM both have the same masses, so GM naught square. We can common GM naught square. This is the mathematical expression for the moon B net force. Now, could the expression part C support your reasoning in part BA? Okay, explain your reasoning. So answer is yes. What is the part B1 answer is answer we can find this one. Okay, how the net force moon A is larger as compared to the moon B. Is this justified from the mathematical tool? So we can see that I have the given the answer yes. In the equation of FB, the first term depend upon our 1 over RB square, which can be very large because the moon B is much closer to the planet B. Even second term showing the moon is pulling slightly in opposite direction because there is a minus sign is there, the opposite direction. So moon B will be likely feel stronger overall net force. So that's the answer. So that's the answer of the whole question. If you have any query, kindly ask in a comment. If you like the content, kindly subscribe and share with it your friends. Okay, take care.